Hello learners, welcome to this new video. In the previous video, if you remember, we have discussed how to convert a point given in one coordinate system into another coordinate system. There were a lot of formula, but these formula were actually very easy. If you remember those formulas, you will be very easily solving this type of numerical that we are going to do today. So, in the first question here, it says that we have to convert the given point into a different coordinate system, and here it says that we have to convert into a Cartesian coordinate system. If you remember, the Cartesian coordinate system is x, y, z. So, in questions like these, it will be never specified that the point which is given, it is given in which coordinate system. But it will be very clear by looking at the points like this one. It is very clear that this point is having one linear dimension, so it would be rho, only one angle, so it will be phi, and there is another linear dimension, so it would be z. On the contrary, the B part, which is Q point, that point has two angles. The first one is a linear dimension, that is 4, and the other two are pi by 2 and pi by 6. So pi by 2 and pi by 6 are obviously angles. So the second point which is given, it is given in spherical coordinates. So let us start with the first question. This question says that we have to convert 160-20 degree, which is given in right now rho phi z, into x, y, z. So let us revise the formulas again. So because we need to convert things into x, y, z, the left hand side would be x, and the formula for Cartesian coordinate x in the form of cylindrical coordinate system, it is rho cos phi. So rho cos phi means rho is given here as 1 and phi is given as 60 degrees. So it will be 1 into 60 degree. So the answer would be 0.5. Similarly, y is given as rho sin phi, and rho is 1 and phi is 60 degree. So the answer will be 0.866. So as you can see, we have found out x, we have found out y. Now let us see what could be z. So as you can see, the z in Cartesian or rectangular coordinate system is the same as the z in the cylindrical coordinate system. Here we are dealing with cylindrical coordinate system. So as you can see, the z here would be the same as the z which is given in the Cartesian coordinate system. So z will be copied as it is. No formula is required here. So we are done with the z coordinates also. So the answer can be written as 0.5, which is x, 0.866, which is y, and z, which is 2. So this is our answer of the A part. Now let us see the B part. B part, the point given is 4, pi by 2, pi by 6. The pi by 2 and pi by 6 are given in radians. You can convert it into degrees if you are not comfortable with radians. But if you have a calculator and if you have a radian mode in it, you can also directly solve in radians. But always remember that your calculator should be in radian mode if you are using the angles as pi by 2 and pi by 6. So again, our answer would be in the form of x, y, z. So if you remember that we are having the coordinates in the point in spherical coordinate system. So the formula for x in spherical coordinate system is r sin theta cos phi. So r is given as 4 multiplied by sin theta would be sin pi by 2. Do you remember what sin pi by 2 is? It should be 1. Cos pi by 6. And to save time, I'll directly write the answer. but I'll tell you that cos pi by 6 is 0.866 and sin pi by 2 is 1 and 4 is 4. So our answer would be 4 multiplied by 0.866, that is 3.464. This is our one of the answers. This is the value of x. So coming to y, the formula for y is r sin theta sin phi. So it is 4 sin pi by 2 cos pi by 6, and the answer for this will be 2. I hope you are sitting with a pen and paper and trying to solve this by yourself. Pause the video, try to solve it by yourself. Maybe you will find some of my mistakes. So if you find any mistake, please write it in the comment section. So now what is left? We are left with z. The formula for z is r cos theta. As I told you, you have to remember these formulas, otherwise it will be difficult to solve this very easy type of questions. So r cos theta is 4 cos pi by 2. Oh, cos pi by 2 should be 0. So your answer will be 0. So not a problem. It can come as 0. So let us write our final answer. We are now ready with x, y and z. So the x is 3.464, y is 2 and z is 0. This is our answer of the B part of our first question. Now let us see the second question. This question has only one point, and that point is given in Cartesian coordinate system, and the question says to convert this Cartesian point into cylindrical and spherical coordinate system. So we'll do it one by one. So let's solve the part A. Let me write the heading also so that we remember that what we are going to do. So first question is cylindrical, and we know that cylindrical coordinate system has 3 points, rho, phi and z. It has 3 dimensions, and the given dimensions to us are x and y. So do you remember this formula? Rho is equals to under root x square plus y square. It was Pythagoras theorem. Rho was the hypotenuse. So we know that x is given as 1. So 1 square would be 1, and 4, second point y is minus 4. So square of minus 4 would be 16. So our answer will be under root of 17. So either you can solve this under root 17 or you can write them as it is, but I'll recommend you to solve what is under root 17 and write down the answer. How to find out phi? Phi was tan inverse y by x, and y is minus 4 and x is 1, so I won't write it. So the answer would be minus 75.96 degree. Either you can write this angle as it is, or you can add this angle with 360 degree, and your answer would be equivalent to approximately 284 degrees. So because phi rotates from 0 degree to complete 360 degree, I would recommend you to write phi as 284 degree rather than writing minus of some angle, because minus of an angle is a different way of writing angles, and I would recommend you not to write it, because phi is not having any problem to reach beyond 180 degree. It can reach beyond 180 degree, it can go up to 360 degree, not beyond that obviously. So anything which is less than 360 degree, you can write it as a phi angle. So z is very easy, not a problem. Z can be just copied as it is. So our answer of A part is rho is under root 17. Sorry for my laziness, I have not found out the under root of 17. I would recommend you to do that. 284 degree is phi and z is 3. So this is our answer. Now coming to B part. B part means it wants the answer to be written in spherical coordinate system. The spherical coordinate system has R and r can be calculated as x square plus y square plus z square, and we have all the x, y, z values. So 1 square is 1, minus 4 square is 16, and 3 square is 9. So our answer would be under root 26. This time I have calculated it. It is about 5.1. And what is the next coordinate? Next coordinate for spherical coordinate system is, next dimension is theta, and theta is tan inverse under root of x square y square divided by z. So to solve this, actually under root of x square plus y square we have already solved in the previous part, a part. So it was 17 as you know, and z is 3. So this answer, sorry, I'll have to first write tan inverse of this, right? It is tan inverse of under root 17 by 3, and the answer would be tan inverse of 1.374, which is equal to 53.95 degrees. So only last dimension is left, and that dimension is phi. So do you think we need to find out phi again? As in my explanation in my previous video, I have told you that phi is same in cylindrical and spherical coordinate. So we can use this result, this one 284 or this 284. So good that we have saved some time. So I will directly write down that phi is 284 degrees. So the B part of this question has the answer 5.1, 53.95 degrees and 284 degrees. Let me tell you one thing, that in electromagnetic theory, conversion of the coordinates is not a very frequent question that is asked in the question papers, because it is a rather easy topic. Rather than giving coordinate conversion, what is asked normally is vector conversion, which will be our next video or next topic. You have to convert one vector, or you have to transform one vector which is given in one coordinate system into another coordinate system. So as you know that vectors are composed of points. A vector has an arrowhead and arrow tail, and that arrowhead and tail are nothing but actually they are points. So if you can convert points from one coordinate system to another coordinate system, you can also convert vectors from one coordinate system to another coordinate system, which is a little engaging topic, and it is commonly asked also. So these two numericals that we have solved in the video, they are considered rather easy, but still this knowledge of coordinate conversion is very, very much important, and the formula are to be memorized. They are very important because these formulas will be used in vector conversion as well. Means without these formula, it is very difficult to, it is not easy to convert one vector from one coordinate system to another coordinate system. So hope you have understood this conversion, the two numericals that I have discussed right now. Happy learning, and see you in the next video.